Well, hello. This is a bit late, but at the end of class we stopped at the integral of, I believe it's 1 over x minus 1, and then plus 2x plus 3 divided by x squared plus x plus 1 dx. Okay, and the big issue, of course, is with this second integral, because the first integral we can do a u sub and get, so this is equal to the natural log of the absolute value of x minus 1 plus the remaining integral here dx. Okay, and then basically what you want to do here is you want to make a u sub and see what you need. So let u be equal to x squared plus x plus 1. Then du will be 2x plus 1. And so if you look at the numerator here, you have almost everything, or maybe a little bit too much. So what you need to do, okay, is split it up. So get the 2x plus 1, and then there's a plus 2 left over, so you still haven't changed the value of anything. Okay, and then of course you can split fractions at the numerator but not the denominator level. So this is the integral of 2x plus 1 divided by x squared plus x plus 1 dx plus, and then 2 times the integral, so I'm taking the 2 out in front, 1 over x squared plus x plus 1 dx. And so with this u sub here, we can use it on that middle integral. You'll get this is equal to the natural log of the absolute value of x minus 1 plus the integral of 1 over u du, okay, plus 2 integral of 1 over x squared plus x plus 1 dx. So then you get the natural log again. Natural log of the absolute value of u plus 2 integral 1 over x squared plus x plus 1 dx. Plug back in what u was, you'll get ln x minus 1 plus ln x squared plus x plus 1, and then plus 2 times this last integral, which we'll spend a little bit of time on. Okay, so let's for now just consider this integral here, and in fact we'll just multiply by the 2 at the end, make sure we don't forget. So let's go ahead and get a fresh board here. So we have, what we're looking at is the integral of 1 over x squared plus x plus 1, and the method, the MO for something like this is you have an irreducible quadratic on the bottom, you have a constant on top, you want to rig it to get an arctan, and so you do that by completing the square. Okay, so to do so, you take half of the, you take half of the middle term, so 1/2 of 1, you square it and you add it to your expression, and then you have to subtract it from your expression, dx. Okay, so this term here is x plus 1/2 squared by design. Okay, and then the last term is plus 3/4. You still don't have 1 over something squared plus 1, so you factor out a 3/4 from the denominator, so, and that becomes 4/3 in the numerator. So what you have here is 1 over and then this is x plus a half squared over 3/4, okay, plus 1. Multiplying or dividing by a fraction is the same thing as multiplying by its reciprocal. So this is 1 over 4/3 x plus 1/2 squared plus 1 dx. Pulling the 4/3 inside of the square, you got to take the square root when you do that. So this is 4/3 integral 1 over, and then this is 2x plus 1 over the square root of 3. Oh, penmanship's a little off here. The square root of 3 squared plus 1 dx. And so now I have 1 over stuff squared plus 1, so I allow that stuff to be my u. So let u be equal to 2x plus 1 over the square root of 3. Then du becomes 2 over the square root of 3 dx. Okay, so moving on here, your integral becomes, well, I have to divide by 2 over the square root of 3, so you end up with, what, 4 times the square root of 3 over 2/3. Okay, so the 4/3 is already there, and then the square root of 3 over 2 we gain, and then you have the integral 1 over u squared plus 1 du. Okay, and the constants, we have some stuff that goes here, so this 4 over 2 becomes a 2, and then the square root of 3 over 3 becomes a 1 over the square root of 3, and then the integral of 1 over u squared plus 1 is arctan of u, and then you multiply that 2 over the square root of 3, and then we had to multiply that by 2 beforehand eventually, so then plug back in what u was, so 2 over the square root of 3 arctan of 2x plus 1 over the square root of 3. Okay, so therefore our entire solution is, what did we have? The ln of the absolute value of x minus 1 plus ln of x squared plus x plus 1 plus, and then we had 2 already there, so now we'll have 4 over the square root of 3 tangent inverse of 2x plus 1 divided by the square root of 3 plus c. And that is, folks, our final answer. Okay, so sorry this took a little bit too long, but to get out, but I hope it benefits everybody. Okay.